Hello everyone, let me introduce myself. I am Facundo Carballo and today I will explain you all about atomic functions in Golang. Since how we have to implement that, why we have to implement, and when we have to implement these atomic functions. Before we start with the video, let me tell you that all the code that you will see on this video, you will have it on my GitHub repo. The link to that repo will be in the description of the video. So I recommend you that you have it close to you while you are seeing this video because it will help you to understand better all the things that I am explaining here. After that, I want to tell you something. That is, if you like this kind of videos, please hit the like button and subscribe to my channel because that helps me a lot to grow up on YouTube. So now I will let you with the video. Other synchronization mechanism that we will see is the atomic. Well, this will be the last synchronization mechanism that we will see. Atomic is very similar to Mutex. With atomic, we guarantee that only one coroutine can access to some resource. It's very similar to Mutex. Here in this diagram is show you how works Mutex, but for this case, it's almost the same because with atomic, we guarantee that this resource, this balance variable, get access by only one coroutine, only one concurrent process at the same time. So if one coroutine, one concurrent process are using this variable or this resource, all the other coroutines cannot access to that particular resource. So at the end is the same that Mutex, but with different sentences to declare this synchronization mechanism. So like it's almost the same as Mutex. Well, with Mutex, we want to prevent race conditions in our program. So with atomic, it's the same. We use atomic to prevent race conditions in our program. So I will explain you the same case that I explained you on the Mutex, but I have to explain this again for those who don't see the Mutex section. So where here we just have two coroutines that are working concurrently. These two coroutines want to do the same, that is, read the balance variable and then increment it by 1. But these two coroutines are executing without a synchronization mechanism. In this case, Mutex or atomic. So these two coroutines doesn't have any synchronization mechanism to access to this particular variable. So here on the timeline, we can see that maybe our coroutines execute in this order, and if execute in this order without a synchronization mechanism, we have here a race conditions. Because here our coroutine number 1 reads the balance of this variable, because here our coroutine number 1 reads the value of this variable and gets 0 because at this time it's 0. Then this coroutine quick and gets into execute the coroutine number 2. The coroutine number 2 also read the value of this variable and like at this time it's 0, read 0 too, and well, this coroutine doesn't quick, so this coroutine ends and well, increment the value of this variable by 1, and after that, the coroutine number 1 goes back to execute, and well, this coroutine already reads the value of this variable, so this coroutine already know that this variable has a value of 0, and then, well, this coroutine will end incremented this value by 1. So we'll increment from 0 to 1 instead of what we expect, that is going from 1 to 2, because at this moment this variable has a value of 1. But this coroutine, like this coroutine reads here the value of this variable, this coroutine doesn't know that in the middle another coroutine increment the value or do something with the value of this variable. So to prevent that, we have to use a synchronization mechanism. We can use Mutex or, in this case, atomic. I will show you an example of how to use atomic in code. So here I have, like always, 3 functions. A do-work function, a with atomic function, and another function that is without atomic. I want to show you the difference between using atomic and when we don't use atomic, and well, when we don't use Mutex 2 or any synchronization mechanism. I want to show you the difference between using synchronization mechanism properly and when we not use synchronization mechanism, what happens. In the cases where we working with concurrency, because all of this will never happen if we work in a sequential way. All of this happens when we try to execute multiple routines, multiple processes in a concurrent way. So first, I will show you this without atomic function, what it does. Well, this is a for and loop, so we'll execute every time. And well, here we'll execute 10 routines, and these 10 routines will try to increment the value of this balance, that initially it's 0, by 1. So at the end, this variable must have a value of 10. But what happens? When we don't use a synchronization mechanism like Mutex, or in this case atomic, well, in some cases, the value of this variable will not be 10, will be different from 10. And that's because the race conditions that we provoke here. So first I will show you this, so you can see that I am telling you the truth, that in some cases this balance will not be 10. And well, I forget to show you this do work function. Well, this do work function will receive a pointer of this balance, and this flag that is with atomic, that is a Boolean variable, that, well, will help me to decide in this function if I use atomic or if I not use atomic. So if in this case, without atomic, I just pass here false. So in this case, execute this code, and well, this code doesn't use synchronization mechanism. It's just trying to get into that particular variable and increment the value from there. Like we can see here, we doesn't have any synchronization mechanism. The coroutines are trying to execute directly from the resource, and that is dangerous because can produce race conditions, and it's what we want to see here. Well, if we pass here true, well, we'll execute this part of the code, that is the atomic part, where we apply this synchronization mechanism, but I will explain that later, once we see first this with atomic function in action. So here I will execute this without atomic function to see what happens. So this function will execute every time looking for, in like this case, a balance different from 10. The majority of the time we'll find a balance of 10, but that is the dangerous thing here, because race conditions are not always telling us you have an error here. No, it's in some cases depending on how these coroutines are executed. So here I am getting a lot of values different from 10, and that's because this without atomic function is executing in a for and loop. It's executing every time looking for new balance difference from 10. But well, I have to shut down this function because it will execute forever if I don't shut down this function. So I will shut down this function, and then I will show you the difference between this without atomic function and this with atomic function. Well, here with this atomic function, it's almost the same that we have here, but without the for and loop, and that's because here always we will get the same results because we are applying synchronization mechanisms, in this case atomic. So it's the same. This function executes 10 coroutines, and these 10 coroutines will try to increment this variable of balance by 1. So at the end, the variable of balance will have a value of 10, but in this function always will have a value of 10, and that's because we are using synchronization mechanism. In this case, we are using atomic. So atomic is a package that we import here, so we can use it, and here we have a lot of functions like this: add integer of 64 bits, add integer of 32 bits, compare and swap integers of 32 bits, compare and swap integers of 64 bits. And well, we have here a lot of functions that we can use from this package of atomic. All of those functions of this package of atomic will guarantee us that we are executing this in a safe way. But for me, Facundo, I prefer to use Mutex instead of this atomic, because with Mutex I feel like I have the entire control of when a routine can access to some critical zone and when not. But that's what I feel. Some people maybe like to use Atomic instead of Mutex, but I like to use Mutex instead of Atomic. And well, I just have to show you how this with Atomic function works, but it will show you a balance of 10 in every execution. So, well, I will execute this function to see what happens. And well, here we have a balance of 10, waiting 1 second. I will execute this again. And well, I get here 10 again. I will execute again to show you that I will get 10 again. And of course, I get 10. And that's because we are applying synchronization mechanism, because we are applying here Atomic. And well, that's all for this video. I hope that you could understand all about atomic functions in Golang. And well, again, I will ask you that if you like this kind of videos, please hit the like button and subscribe to my channel, because that helps me a lot to grow up on YouTube. See you on the next video.